Hi everyone. In this video, we are going to talk about thermal inversion and how it relates specifically to air pollution. So we've talked about this urban heat island effect briefly before, so let's compare the difference between the heating of rural and downtown or urban areas. We're not going to really worry about suburban areas too much because we can kind of gauge that they're the in-between of the two extremes of rural versus downtown. So urban areas tend to have higher surface and air temperature than the surrounding suburban and rural areas. This is mostly due to albedo, so heat absorption versus reflection. So the urban areas have lower albedo because concrete and asphalt are darker in color and therefore absorb more of the sun's energy than areas with vegetation, which are lighter in color. Those vegetative areas still absorb sunlight, but not to the same degree that those darker buildings and asphalt absorb heat in our downtown urban areas. So we can kind of see with these red squiggly lines that the downtown area is absorbing more heat than our rural areas that have not been developed. We also have less evapotranspiration due to this urban heat island effect. So think of it kind of like us as humans sweating, right? When we're doing strenuous physical activity, we tend to sweat and that sweat cools our bodies down. This is the same concept. So water evaporating from surfaces and the transpiration from plants carries heat from the surface back up into the atmosphere, cooling the rural areas and suburban areas, which have more vegetation. And because our urban areas have less vegetation, we don't get this same effect. So we get more cooling in the rural areas and less so in the urban areas. So normally the atmosphere is warmest at Earth's surface and cools as altitude rises. We talked about this with adiabatic heating and cooling. As air moves up into the atmosphere further away from the surface, it cools and expands. So we tend to have our warmest atmospheric layer closest to the surface, and then it gets colder as the air rises. Because warm air rises, the air convection currents carry air pollutants away from Earth's surface and distributes them higher up into the atmosphere. However, on occasion, we can get the first and the middle layer to flip-flop. That is the thermal inversion. So this happens when the cooler air mass becomes trapped near Earth's surface. So they essentially switch positions. This is either due to a warm weather front moving over top of that colder air layer or due to hot urban surfaces cooling overnight while infrared radiation absorbed during the day is still being released. So typically this is going to happen in more of a valley. So if the city or area is at the bottom of a valley, we can very easily have this thermal inversion, but it's not unheard of in urban areas to have this occur as well, as that urban surface cools overnight and the infrared radiation is still being released. The issue is that the pollutants that are typically given off and redistributed to the upper layers of the atmosphere become trapped because you have that warmer layer of air trapping the pollutants from moving up further into the atmosphere. You can kind of see this if you're driving near the city. It's not necessarily a thermal inversion, but if you've ever seen like smokestacks from industry giving off that condensation or what looks like smoke up into the atmosphere, and instead of the smoke continuing to travel straight up, it kind of travels straight up and then flattens off. That's because it's encountering a warmer layer of air than the lower portion of the atmosphere is experiencing. Some effects of thermal inversions are air pollutants, obviously smog, particulate matter, ozone, sulfur oxides, and nitrogen oxides get trapped closer to the surface. This can lead to respiratory irritation. We can have asthma flare-ups leading to hospitalization, worsen COPD, and emphysema. We can decrease tourism revenue, so that would be an economic impact of thermal inversions, and we can decrease the rate of photosynthesis with our plant life. And that is it for this section. If you have any questions, as always, feel free to ask.